Hey guys, welcome back to another video. You're speaking with Roland and I'm your tutor. In this particular video, we'll be doing Euclidean geometry. We'll take a nice 10 to 12 minutes to look at it properly from a 360-degree point of view and just making sure that you understand everything from the basics through to the complicated stuff. And I understand that when it is seeming complicated, it's generally because you don't understand the rules and you need to go back and watch videos like this that explain everything from the basics. So with that said, let's jump right on into it and get started. So we use two fundamental rules. There are two fundamental types of measurement. We use angles and we use distance. So angles we generally write by terms of theta or in terms of x, and distance will be along lines. Angles obviously are between lines and they measure the gap between them, up and down, and distance is just distance in terms of from A to B or X to Y. So as you can see here, I'm drawing a nice cross. As you can see, that is an angle. We're representing that by a letter A. The opposite angle is called C. The other angle that I've drawn here is B, and the opposite angle for B is going to be D. Let's move forward. You now know that you've got opposite angles of A and C and B and D. I'm going to draw up a table for us so that we can go through the definitions of the terms and then the relevant properties, and I'll obviously give you an example. Just to elaborate on what we're doing Euclidean geometry. Right, with an acute angle, we know that the angle is always less than 90 degrees, so we write the angle A with a little hat on top of it. The property would be A is less than 90 degrees but greater than 0 degrees. As you can see underneath property, always make sure to write an angle A with a little hat on top of it, just to illustrate the fact that it is in fact an angle. Right, let's do a right-angled triangle. If you can't remember, a right-angled triangle is a 90-degree triangle. So that means that you have a triangle with at least one angle that is equal to 90 degrees. So in this case, we're looking at a right angle, which is an angle equal to 90 degrees. We represent this by drawing a perpendicular line to another line and a box to represent the 90 degrees. We'll now move on to an obtuse angle. And as you saw, you had an acute angle in blue, a right angle in green, and an obtuse angle in yellow. I've circled the relevant angles. As you can see, I've labeled A for the blue, acute angle. The opposite angle to that would be C. The obtuse angle now is D. We say that the angle is greater than 90 degrees but less than 180 degrees. The two angles in the diagram above are angles B and angles D, both of which are obtuse angles. I've color coordinated this so that it's easy for you to see which angles are which, and they'll easily stand out from each other. Now, let's move on to a straight angle. A straight angle is an angle that is equal to 180 degrees. There we go. I'll illustrate this further on the diagram above. So if we say the angle A plus the angle B, or the angle B plus the angle C, we'll see that we have a straight angle. Let's move on to the purple one, which is the reflex angle. Now, a reflex angle goes further than 180 degrees. It's less than 360 degrees, but it is greater than 180 degrees. Notice how we've used a staggering method, starting at acute and moving on towards the reflex angle. If we were to say angle A plus angle B plus angle C, we'd see that we'd have an angle that is greater than 180 degrees, but less than 360 degrees. That's illustrated in purple for your ease of use. Right, now you see an obtuse angle at D, represented by the yellow, and once again by B, also in yellow. Let's take this further. We have this in red. Red represents the straight angle, which is equal to 180 degrees. So A plus B and B plus C are equal to 180 degrees. Now it gets a little bit more interesting. We will be talking about adjacent angles. Adjacent angles are angles that lie next to each other. As you can see, I'm writing it over here, and these are angles that share a common line. So we call this line a vertex, and this will be illustrated a little later on. So these angles share a vertex and a common side. We're talking about angles like A. You see how A and B share a common side and a vertex. There we go, that's represented there. Same for A and D, they share a common side. This makes them adjacent angles. So there we go, we've got A and D. We could also say C and D, or C and B, or A and B. As long as they share a vertex and a common side, we call them adjacent angles. Alright, so B and C, A and B, C and D, and A and D. The next one we'll do is the vertically opposite angle. Now, vertically opposite speaks for itself. These are angles that are vertically opposite each other. For instance, we looked at B and D, they are vertically opposite, and A and C are vertically opposite. So here is the definition. These are angles that share a vertex and they share a common side. So it's much the same in terms of definition as the adjacent angle. However, they need to be vertically opposite each other. So as you see, you've got A and C, and then you'll have D and B. They share a common vertex and they share a common side. There we have it. We have A is equal to C, and we have B is equal to D. Notice that I have not stopped putting little hats on the letters to illustrate the fact that these are angles. Now moving on, we'll need to talk about supplementary and complementary angles. Supplementary angles. These angles add up to 180 degrees. We also have complementary angles, and these you'll see in the next step. Supplementary angles are two angles that add up to 180 degrees. Right, make sure to remember supplementary means 180 degrees. It's very important, and you'll notice why later. So there we have it. We have the likes of A and B, and we have the likes of C and D. We can also say A and D and C and B. As long as they are angles on a straight line and they add up to 180 degrees, we call them supplementary angles. So here we have it. We have A plus B. Notice the hats, they're both equal together 180 degrees. C and D together make 180 degrees, and once again that is a supplementary angle. Make sure to take notes of that. Now we have the complementary angles, and the complementary angles also have a value that they add up to make. So these two are two angles that add up to a value of 90 degrees. So that's complementary at 90 and supplementary at 180. Take notice of that. Complementary is 90 and supplementary is 180. Make sure not to get confused. It's very easy to remember that. So 90 comes before 180, just like C comes before S in the alphabet. Very nice and easy. Let's look at the revolution. The revolution is the sum of all angles around a point. The revolution equals 360 degrees. There we have it. We have the angle A plus the angle B plus the angle C and plus the angle D. They all equal 360 degrees. Here we go. We have the entire set of angles that add up together at 360. All of the angles around a point. Easy game.